Right under our feet, crisscrossing entire continents and even diving under oceans, there's this massive, totally invisible network that, well, it pretty much powers our entire world. It's an unseen superhighway, and it's carrying the energy that fuels everything we do. But have you ever really stopped to wonder how it all works? I mean, think about it. It seems almost impossible, right? You've got crude oil that's pulled from some of the most remote places on Earth, and somehow it has to end up as gasoline in your car. So, how does it make that incredible trick? Well, it's not magic. It's actually a masterpiece of engineering on a truly global scale. And when I say global scale, I am not kidding. The sheer size of this network it's just hard to wrap your head around. All told, there are over 2 million miles of these energy pipelines around the world. That's enough pipe to circle the Earth more than 87 times. It's a colossal system, and most of it is hiding in plain sight, just beneath our feet. So yeah, you can forget the image of some simple straw sucking oil from the ground. A better way to think of it is as a vast, high-tech interstate system. It's buried just a few feet underground, and it's operating nonstop, 24 hours a day, 365 days a year. This is the silent, vital system that absolutely never sleeps. But a highway this massive doesn't just appear out of nowhere. Building it is a monumental feat of planning, raw power, and incredible precision. So let's break down how these arteries of energy actually get put in the ground. It's a multi-stage marathon, really. It all starts with super meticulous surveying and getting all the right permits, trying to minimize any impact. Then, a path gets cleared and a long trench is dug. After that, they take these massive 40-foot sections of pipe and literally bend them to perfectly match the curves of the land. They're all welded together, and get this, every single weld is x-rayed to make sure it's perfect before the whole thing gets coated to prevent rust. And finally, before it's even buried, the entire line is tested with high-pressure water to guarantee there are no leaks. Only then is the land on top put back to the way it was. And this isn't just automated work, not by a long shot. It takes skilled crews out there on the ground managing every single detail. Here, you can see them installing something called a cathodic protection system. It's a fascinating piece of tech we're going to get into in a minute, and it's absolutely essential for protecting that pipe for decades to come. Okay, so the highway is built. The pipe is in the ground. Now, how in the world do you get millions of barrels of oil to actually move through it, sometimes for thousands of miles, fighting against friction and going uphill? Well, the answer is just pure power. Say hello to the engines of the pipeline, pump stations. These places are the real heart of the system, and they're strategically placed every 20 to 100 miles or so. Inside, you've got these massive pumps that act like boosters, creating the immense pressure it takes to keep all that oil flowing steadily down the line. Now, you might be imagining oil just rocketing through these pipes at crazy speeds, but the reality is actually pretty surprising. It moves at about 3 to 8 miles per hour, which is basically a brisk walking pace. For this superhighway, it's not about speed. It's all about relentless, efficient, non-stop movement. To put that into perspective, for just one single drop of oil to make the trip from the energy hub in Houston all the way up to New York City, that's a journey of 2 to 3 weeks. It's a slow, steady, and incredibly reliable trip on this underground superhighway. Right, so a system this huge and this important can't run on brute force alone. It needs a brain, a really sophisticated network of technology that makes sure every single mile of that journey is safe, secure, and constantly watched. This is where the pipes get smart. So to maintain this massive highway, engineers use a very clever tool called a pig. And no, not the farm animal. A pipeline pig is this high-tech device they send right through the pipe to do all sorts of jobs, from cleaning out debris to using sophisticated sensors to inspect the pipe wall for any signs of wear or damage, all from the inside. The entire network is watched over from a central control room, kind of like air traffic control for a major airport. They do this using something called SCADA systems. These systems collect real-time data on pressure, flow, and temperature from sensors all along the pipeline. It lets operators see exactly what's happening everywhere, all at once, and they can even operate valves hundreds of miles away remotely. And safety is everything. There isn't just one system for detecting leaks. There are layers upon layers of technology all working together. You've got acoustic sensors that are literally listening for the specific sound a leak makes. Fiber optic cables can sense tiny temperature changes. There's even ground-penetrating radar and infrared cameras, all backed up by automated valves that can shut off a section of the line in an emergency. It is a true defense-in-depth strategy. Hey, remember that system the crew was installing a few minutes ago? Here's how it actually works. It's called cathodic protection, and it is genius. A very low electrical current is run through the pipeline. This current basically tells any natural corrosion, hey, don't attack the pipe, attack these other metal rods over here instead. Those rods are called anodes, and they're designed to be sacrificed. So corrosion eats away at the replaceable rods instead of the pipeline itself, protecting that pipe for 50 years or even more. So we have this one incredible highway, but we need to transport different kinds of cargo, right? We've got gasoline, diesel, jet fuel. This is where the system gets even smarter, using a process that lets this one superhighway handle all sorts of traffic. Which brings up a really great question. If you've just got one pipe, how on earth do you send all these different fuels through it? Gasoline, diesel, jet fuel, without them all just mixing together into one big, useless cocktail at the other end? The answer is a really clever process called batching. What operators do is send one product, let's say gasoline, for a few hours, creating this massive, miles-long segment. Then they'll switch and send a big batch of jet fuel, and then after that, a batch of diesel. These huge, distinct batches flow one right after another down the exact same pipe. It is an incredibly efficient way to make one pipeline do the work of three, and it saves an enormous amount of money. So the next time you're at the pump filling up your car, just take a second to think about it. That gasoline didn't just magically appear there. It took a long, slow, and amazingly high-tech journey, traveling for weeks on this unseen superhighway to get from a distant refinery right into your tank. And this all brings us to one final fascinating thought. This incredible infrastructure was built for oil and gas. But as we start looking toward the future, there's already work being done to see if these very same pipelines could be used to transport other things, like hydrogen fuel or maybe captured carbon dioxide. What will these hidden highways carry in the decades to come? It's a huge question, and the answer could really define our energy future.